Hi everyone, my name is Zhongheng Cheng, and I'm really thrilled to become a contributor to Red Hat Lab as part of Google Summer of Code 2024. My project is called FrameBlending by LLMs and is guided by my mentors, Susie and Professor Turner. This project is based on the significance of frame semantics, and the frame is the concept that enhances our understanding of language by interpreting words through their underlying conceptual structures. And this approach not only deepens our insights into the linguistic itself, but also it has some profound applications in fields such as economics and politics. So our goal for this project is to explore the capabilities of large language models in generating frame blending examples by leveraging techniques such as prompt engineering, fine-tuning, and RAG, the retrieval augmented generation, with FrameNet datasets. And throughout this coding period, I have developed several auxiliary scripts to work with the FrameNet dataset and open source LLM models, particularly the Llama 2. And additionally, I have created a terminal-based GUI application called FrameBlender to streamline the generation process on a high-performance computer cluster platform at Case Western Reserve University. And with this app, users can have a more structured and easy to access experience about generating frame blending examples and giving feedbacks for the generation results. And in this presentation, I will briefly discuss the purpose and the functionalities of each code component I have developed. So firstly, we wanted to use RAG to let LLM models generate results based on the FrameNet dataset, instead of merely relying on its pre-trained data. Because as we all know that FrameNet dataset has a large number and a large range of documented and annotated frame data. And this dataset is expanding over time. So RAG would improve the performance of generating results and in the meantime allow its scalability at the same time. Yeah, therefore, the first script is the FrameNet XML parser. This script can convert the XML format data into JSON files while leaving out unimportant information such as frame ID and created date, etc., and making it more convenient for the follow-up processing. And this code was originally developed by Rohan and modified by me to accommodate my project. And you can also check out Rohan's profile. He's a really excellent programmer and my peer contributor to Red Hat Lab. And then to implement this RAG function, I utilized the Llama index to create this function for Llama 2. And as a brief introduction to how Llama index works, it will basically create a vector database based on the reference data. And in my case was JSON format files of FrameNet data set. Then it will create a query engine for LLMs to generate contextually relevant responses based on the indexed information. And so with this help of Llama index, I let Llama 2 have reference data from FrameNet dataset while generating, so that it will have a better understanding of how these frames are used and have a higher relevance to the FrameNet dataset. And secondly, to help users better choose frames for blending, I developed a hierarchy analyzer to show the hierarchy tree of frame relations based on the inheritance, perspective, usage, and subframe relations from the FrameNet dataset. When you look into a frame in a FrameNet dataset, you will find this frame relations, and it's all connected from one frame to another frame. And my code currently supports these four relations along with its reverse one. And also my code will store the relation as a tree, making it more flexible to demonstrate or fetch the relation tree of any single node for the follow-up processing or demonstration. And moreover, it is made easy to display the tree either in command line or to be saved to a file storage. So as a brief demonstration of the usage of hierarchy analyzer, here I have entered my working directory and create a new file called tamdemo.py. I have import some functions from the frame hierarchy analyzer I have developed. Also, I have the frame folder containing all the XML format file from the FrameNet dataset. So first thing I do is to get all the frames name list from the frame folder, and I will set the frame relation I want to inheritance, and then to get a root of the hierarchy tree by calling the analyze hierarchy function. So in this tree, when I want to find a frame, let's say we call it event, and to print the hierarchy tree structure of event's inherited child. Okay. When we run this script, it will print out all the tree structure of the frame event in the terminal output, and we'll display the structure of all the inherited frame relations. Yes, and we can also use the save hierarchy to file function to have this output saved to a file for future use. For example, here is the inheritance file I have created. The relation is inherited by, and here is all the structure for the FrameNet dataset I have in my directory. We can also have perspective and subframe and usage hierarchy ready for our development. And thirdly, in order to have the generating and evaluation process set up, I created a command line GUI application called FrameBlender. So this app is intended to walk users through generation, configuration setup, frame selection, generation, and evaluation processes. Here is a demonstration video. I can show you how it works and how we can run it on the case HPC high performance computer cluster. Now I have logged in as the XC808, which is me, to the case HPC high performance computer cluster. Yeah, and I have cloned my work directory GSOC 2024 FrameBlending to my Galena home and stored all the automated shell scripts under the shell_scripts folder. I'm preparing for temporary directory on the case HPC platform, and the installation and running of FrameBlender, the application. Firstly, I'm checking the config.sh. My user ID is ZX808, and I will request a GPU node for running this app. Okay. First, I will create a temporary work directory on the case HPC. After it's done, we will have to request the GPU node to prepare the environment to run the FrameBlender app. Okay, after this job has been allocated resources, yes. And here is where I store my data, the evaluation data. On the top left is the data directory of my Galena home, and the bottom left is the data I have stored in my temporary working directory. I will show you that after we have done the evaluation steps, we will have to use the script to copy the evaluation data from my temporary working directory to the Galena home, because we have to store it persistent. We will use /FrameBlender to enter this FrameBlender interface. So the key windows will display all the keys you can use when using this application, and a query engine displaying whether the query engine is ready or not. And firstly, we will be entering the settings window. We will use arrow keys like up and down to switch from different settings, and left and right to change the settings. The settings includes how the prompt we want it to have, like zero shot, one shot, few shots, or a chain of thought prompting. And the third line is the rhetorical or non-rhetorical, so that we will specify if we want it to be like apparently rhetorical in the prompting. And we will use tab to switch from different windows, like entering the frame 1 input. After we enter a full frame name, the hierarchy window will pop up immediately, so you can choose. So you can further choose a frame in the hierarchy window. And after you have entered all the frames and confirmed all the frames you have entered, I'm waiting the query engine to get ready. Yeah. So when you have confirmed all the frames you are preparing, you can press / to start this generation process. It will take a few minutes, so just take a patience and enjoy your coffee or something. After some time, it will show this generating result in this frame blending window. And you can use tab to switch to the evaluation window to give feedbacks on this generation result. You can have ranking from 0 to 10 for different entries of the evaluation matrix, such as completeness, clarity, relevance, depth of understanding, coherence, execute time, and additional nodes. Yes, and after entering all this evaluation items, you can press enter to confirm this and to submit this feedback and store it in a file. We store for the evaluation data, which is the bottom left one. Yep. So after we submit this, the newest evaluation data is temporarily stored in the temporary working directory. We will have to use shell scripts I prepared for you to copy this newest data to the Gleaner home. And that will be a typical workflow of the FrameBlender. Here is basically what I have done for this project this summer. And it is a pity that this ending time is approaching so fast for GSR period. But for future improvements, I would say the first is to improve the model. By the time I finish this project, Llama 3 has already come out, and there are more powerful models even for Llama 2 compared to the one I'm using, such as the 13 billion and the 70 billion parameters models. Having a better model means better fundamental capabilities. And besides that, we can apply training to raise them to the next level. So with the FrameBlender workflow and the evaluation data we might collect in the future, we can feed this generation result along with their evaluation data back into the model to train the model to understand how to construct better FrameBlender examples. And lastly, I would like to extend my heartfelt gratitude to my mentor, Susie, and Professor Turner for the continuous and unwavering support and guidance throughout this project. Susie has become so instrumental in providing me with a wealth of resources to understand this project deeply and to navigate my progresses. And meanwhile, Professor Turner has consistently offered his support, like connecting me with other Red Hat contributors, such as Rohan, and technical support teams of K's HPC platform. And this made this contributing period at Red Hat Labs so efficient and meaningful. It has been a time that I honed my programming skills and was able to meet so many great guys. And I believe this mentorship has played a super important role in fostering strong connections and facilitating the transfer of knowledge within the Red Hat Lab, Red Hat community. And I'm looking forward to continuing contributing to this open source projects, and I'm also And I'm also looking forward to keeping a good relationship within the Red Hat community. Thank you.